For today's maths lesson, we are going to look at frequency trees, which are used when you've got more than one piece of information. And they're actually quite straightforward once you know how to set them up. So for today's video, I'm going to do two examples which you can copy along with me. And then there are some questions on a worksheet for you to have a go at afterwards. So the first example is here, and it says that in a group of 80 people, 60 are right-handed. And out of the right-handed people, 40 of them have blue eyes, and the rest have brown eyes. And out of the left-handed people, 16 have blue eyes, and the rest have brown eyes. So the way that I'm going to set out my frequency tree is to start off with the total number of people on the left-hand side of my page, which is 80. There are 80 people altogether, and I'm going to put that into a circle so that it stands out. Now the next piece of information I'm given is that 60 people, or 60 of them, are right-handed, meaning that the rest are left-handed. So my first two options for the 80 people is that they're either right-handed or left-handed. And in the question it says 60 are right-handed, and obviously the rest are left-handed. So if 60 are right-handed, how many are left over? Well, there are 20 people left over that must be left-handed, and I'm going to put those two numbers into some bubbles as well so it stands out. Now it says, out of the right-handed people, which is these 60 people here, 40 of them have blue eyes, and the rest have brown eyes. So there are two options again. The first option is blue eyes, and the second option is brown eyes. And it says that 40 have blue eyes, so 40 are going to be on this section here, and the rest have blue eyes. Well, if I've got 60 right-handed people, 40 of them have blue eyes, then the rest must be 20 have brown eyes. 40 add 20 is 60. Now for the left-handed people, I've got 20 altogether, and it says out of the left-handed people, 16 have blue eyes. So my two options again are blue and brown. So blue eyes, there are 16 people. And if 16 have blue eyes, well, how many are left over that must have brown eyes? Well, 16 to get up to 20, I need to add 4. So 4 people have brown eyes. And that's my frequency tree completed. Now, one thing that I always do to check that I've done my workings right is to add up these 4 numbers. And I should get the total number of people, which is 80. So if I just quickly do 40, add 20, add 16, add 4, then I start off my unit. So 6 add 4 is 10, 4 add 2, add 1 is 8. So it's 80, which is right. That's the total number of people is 80. Now the type of question that you could be asked to do with probability using frequency trees are like these two questions that I've got on the screen on the right. So if one person from the whole group is selected at random, what is the probability that they are right-handed and have brown eyes? So let's start off with that one. Well, where on this frequency tree is the group of people that are right-handed and have brown eyes? Well, first of all, they must be in this section here. They must be right-handed, so they must be in this group of 60. But they also must have brown eyes, so they must be in this section as well. So there are 20 people altogether that have brown eyes and are right-handed. So this, for number 1, is the section that I'm interested in. And therefore, if I was going to look at a probability, well, I would say that there are 20 people out of 80 altogether. So the probability would be 20 out of 80. Now I can simplify that a little bit. If I wanted to know how many 20s go into 80, well, there's 4 20s that go into 80. So I could simplify this to a quarter. 20 is a quarter of 80. Now question number 2 asks for left-handed people that have blue eyes. So if I'm looking for the left-handed people, I must be in this group. And I want the ones that have blue eyes, which are in this group here. So for question number 2, I'm interested in these 16 people. And therefore the probability is going to be 16 out of 80 people altogether. Now if I simplified this probability, I know that there are 5 lots of 16 that go into 80, or I could say that 16 is a fifth of 80. So that's just a simplified version, a simplified probability, but these two would have been absolutely fine. So that is the first example done. I'm going to do one more on this video, but if you want to copy down what I've done already, then you can pause the video now and give yourself a chance to catch up, and then restart the video when you're ready to do example number 2. Okay, so example number 2, I'm going to turn the page, take these away, is this. Now I've purposefully made the numbers less round numbers, shall we say. So it might be a little bit trickier, but I'm going to go through it slightly quicker, as I don't think I need to do as much explaining as I did in the last example. So this time, in a group of 120 people, so the first thing I'm going to do is write 120 on the left-hand side of my page. 65 are female, and the rest are male. So I can get the first 2 options done straight away. So it says the 2 options are female and male, and it says that I've got 65 females and the rest are male. So I need to work out 120 take away 65 will give me the number of males. So 120 minus 65 would give me the number of males, which is 55. Quick way of checking, if I add up 65 and 55, I get 120, which is what I want. Now it says, out of the females, 49 play sport for their school. So my first option for the females is play sport. And therefore, the rest of the people must not play sport. So I'm going to have not sport, or no sport would be fine for my second option. And it says that 49 play sport and therefore the rest do not. So what must I add to 49 to get up to 65? Well, that means there must be 16 people that do not play sport out of the females. Now it's the same 2 options for the males, play sport or not sport, or no sport. And in the question it says, out of the males, 17 do not play sport for their school. So 17 do not play sport for their school. And I need to work out, then the final thing I need to work out is how many of the males do play sport. And to do that I need to do 55, take away 17, which would be 38. Now I said in the last video that I always check that these 4 numbers here add up to the total number of people, which is 120. So I'm going to do that first. 49, add 16, add 38, add 17. Well, 9 plus 6 is 15, plus 8 is 23, plus 7 is 30. 4 plus 1 is 5, plus 3 is 8, plus 1 is 9, plus 3 is 12. So 120. So I know that I've got these 4 correct, because they add up to 120. Now my 2 questions for this probability frequency tree rather is that if one child is selected at random, what is the probability that they are a male who plays sport for their school? So for this question number 1, I'm interested in the males who play sport, which is this group of people here. So the probability would be 38 out of 120. Now, I'm going to use a calculator here. to simplify this probability. So if I did 38 out of 120, I get a simplified probability of 19 out of 60. So all I've done there is divide the top number by 2 and divide the bottom number by 2. Now question number 2 asks for the females who do not play sport for their school. So I'm interested in the females who do not play sport, which is this group of people here. So the probability, I'm going to write it underneath for question number 2, would be 16 out of 120. And again, I can just use my calculator to work out what the simplified probability would be. So 16 out of 120 will give me a simplified probability of 2 out of 15. I'll say what I said on the last video, is that if I just left it as 38 out of 120 or 16 out of 120, they would be fine. But I suppose a better answer would be the simplified version, which I've put as well. So that is it. They are the 2 examples on frequency trees. You've got 4 questions to have a go at on the worksheet for today's lesson, which are really similar to the 2 that I've done on this video. And remember to take a photo of the work that you complete today and upload it to Google Classroom so that your teacher can see what you've done.